Hello everyone, it's October 16th. Surprisingly, unsurprisingly, we're going to do the best time to buy and sell stock again today. I'm pretty sure we have covered this yesterday, so we're going to just go through this very fast. Yeah, it's at least 2 transactions. What should I do with this? So I already done this from yesterday. Alright, so delete this and actually we should not delete this. Like this, right? I mean, we have to do it just to count for today, but we did it yesterday, so it'll be fairly straightforward for us. And we're gonna go through the state machine one more time, right? Go through it one more time. It's always good to go through the state machine one more time. All right, so I think this one is what? At most 2 transactions. So at most 2 transactions, we have 4 states, right? We have hold 1, right? We're gonna have hold 1, empty 1, hold 2, and empty 2, right? And then hold we're gonna just do the inf. That's how I like to do it. So import math. All the hold and the inf or the empty gonna start with 0. Right? And then I'm gonna say for P in prices. So a difference is hold 1 can only get from itself, right? Or we're gonna set it to minus P. Because that's the price. Because for hold 1, we're gonna buy it, but we're not buying it from any source, right? So we just say H1, E1, H2, E2, right? So H1 always going to be maximum H1 because it's no option, or minus P, right? And then E1 can be itself, or it's from H1 we sell, right? So it's going to be H1 plus P. And then H2 is going to be no option, or E1 buy, so E1 minus P. And then E2 is going to be H2 plus P. Right, so we go through all this and then return. I mean, we always return E2 because it's not possible to return E1. Because if you say I'm going to return E1, then you have more chance to buy and sell again. So E2 will be at least not smaller than E1. Alright, so we can just go through the same test cases as we went through yesterday. And then see how we get. It should be correct because we done it yesterday. Okay, this one should be 4. This one shall be 0. And this one shall be 0. Right, and all this alright, here we're gonna be prices and max profit prices. Run it. Yep. So we pass everything. Submit this again. This is just for passing today's challenge. Nothing else, just passing the challenge. Okay, submit again. See, we have so many times we've done this. Alright, so we just record 470 days. Alright, nothing more to see. We already done this yesterday. So let's try another problem. I'm gonna go here. This one doesn't count. Okay, let's see. We're gonna do a hard question because it's Saturday. So we're gonna go difficulty, which is hard, and pick one. So what we got? Student attendance record. Nope, not done this before. Okay. An attendance record for a student can be represented as a string where each character signifies whether the student was absent, late, or present on that day. Record only contains the following 3 characters. Any student is eligible for an attendance award if they meet both of the following criteria. Was absent, A for strictly fewer than 2 days total. Was never late for 3 or more consecutive days. Given an integer n, return the number of possible attendance records of length n that make a student eligible for an attendance award. The answer may be very large, so term modulo this. Alright, let's formulate this problem. Right, so the criteria is student was absent for strictly fewer than 2 days. Right, so we're gonna have 0 absent, 1 absent, strictly fewer than 2. So that's only 2, either 0 absent or 1 absent. Was never late for 3 or more consecutive days. So it can be late for 3 consecutive. Wait, hold on. Was never late for 3 or more. So we can do late. So late. That's the maximum we can do for consecutive late. But it can be not consecutive late. It can be like late, interspersed. Is that a word? Maybe interspersed with present, like LP. That one will work. But we cannot do LLL. LLL will fail. But LL is fine. And then just all else, not consecutive else. So if we think about it, it can be a single L, right, is an element, and LL, we can consider that as another element. So these two, we need to make sure that these elements do not adjacent to each other. But L can be adjacent to L. L can be adjacent to L. Anyway, okay, so n equals 2, right? N equals 2. So we can say all present, right? All present is always good. And then because I can do 1 absent, right? We can do 1 absent. So all present, and then each P can be replaced by an A. So PA and AP, they're all good. Now I cannot do any more absent. That's the maximum absent we can do. So that's it. All present, 1 absent, we're done. Now it's just playing around with late. Oh, hold on. An AL and LA, that also work. Huh. What would be the ideal for this? Right, so we will go P, and then we kind of removing, all right? Removing P by L, or removing P by A. So yeah, so these are good, but now L needs to take into consideration. And we can have 1 L, right? Because it's never late. We can do 1 L. So P and A, so P by itself, P and A, and then P and L, right? So P and L will be start from 1 L, so PL and LP, and how about 2 L's? We can do 2 L's. Yeah, so 1 L, we can find all the possibility for 1 L, and then for 2 L's. Hold on. Let me think. What's the good strategy for this? How about recursion or DP? So if we do DP, we say we have a bunch of n, right? We have n, and then we say the first position. If it's p, then there's no restriction on the remainder. So the maximum will be the remainder. The remainder is what p is fine. Okay. Now, if the first one is an a, then the remainder cannot have a. Right? Remainder can have p, can have l, but remainder cannot have a. Right? So no a. Remainder is no a. If I start with L, then the remainder, what's the remainder if I start with an L? If I start with an L, then the next one, if it's we can do a P, then there's no restriction. If the next one is A, then it's just no restriction, with the same restriction, right? And the next one is L, that means the remainder cannot have L. Okay. So what? So we're gonna have the length, and whether it has A, allow A, allow L. So it's like three levels DP, 10 to the 5th. Ooh, I feel like in a timeout. 3 levels, 10 to the 5th. If it's 1, right? If it's 1, then we have 3 in total. If it's 1, it's not just 3. It's there's no restriction, which means allow. So saying it's a 3 level. We have allow A and allow L. So if we go 3 levels. First level is n. Okay, so first level is n, and then within n, we're gonna have it's a 2 by 2, right? It's a 2 by 2, so it's gonna be 0, 1, and 0, 1, and then that's gonna be allow A. Let's say the rows is allow A, and the column is allow L. So if it's 1, then if allow, so it's 1, 1, allow, it's going to be 3. If it's neither allow, then it's a 1. And if I allow A, but does not allow L, it's 2. And the other one is 2. So, okay, so that's that. How about 2? So 2 is still going to have a 0, 1, 0, 1, right? So with 2, if the first one is P, then the second one is going to be allow. So it's a 1, 1 situation, which gives us 3. If the first one is an A, then the second one will be not allow A. So that's not allow is a 0, 1 condition. So that's a 2. So 3 plus 2. And if the first one is an L, then the second one. And the second one is actually, the first one is L, then the second one has 3 situations, right? The second one, if it's a P, the second one can be, it's actually 3, because we only have 2, so it's 3. So that added together is going to be 8. That's exactly what this is, right? 8. Okay. how about 3, right? So we have done this. Oh, I have forgot to record. So for 2 situations, if it's P, then it's allow, then we have 3. So does that go into allow? Yeah, that's going to go into allow. And then when it's A, but that doesn't, I'm not, hold on. I want to know, given 2, right, given 2, what is the allow situation, right? Allow situations, we allow both, we allow all. Oh, that's 8, right? That's 8. Hold on, we allow, what does allow mean? Allow means there's no restriction, right? That's allow means no restriction. Which means we can pick anyone, right? And then we need to try to find out what is, say, don't allow A and don't allow L, right? If don't allow A and don't allow L, then it's just all P. That's always 1. So 0, 0 situation will always be 1, right? And then a 0, 1 situation, so we allow L but don't allow A. So we do not allow A, but we allow L. So we need to compute that one. We compute that one already. We don't allow A, which means, let's see, the first one is going to be P, right? And the second one cannot allow A. So we don't allow A. So if we don't allow A, then we go to the one situation. We don't allow A. So one situation is going to be 2, right? So we're going to be 2. Or the first one can be L, and the second one don't allow A. Don't allow A. Yeah, don't allow A is going to be 2, and I can allow L, right? I can allow L, so that's 2 again. So that's actually 4, right? So if we do not allow A, but we allow L, that can give us a 4. So basically, we take all the A out. Yeah, that's 4. Okay. So if we allow A but do not allow L, so we have P allow A but do not allow L. So that's 2, right? And allow A, so we can do A, and the second one is going to be not allow. So which one is only 1? So that's going to be 3, right? 3. So we allow A but don't allow L. So we have 1, 2, and 3. We allow A but do not allow L. Okay, so that's that. Now what we're going to do is going to try 3 and see if this thing scales well. I need a piece of paper. Alright, so in the situation of 3, right? Again, we're going to have this table, a 2 by 2. So just allow A and allow L, 0, 1. So now we have 3, right? Again, we first do we say we first one we put a 0, 0 is always 1, right? There's no question. 0, 0 is always 1. And then we're gonna put first one is P. Then if the first one is P, we have we can do 1, 1, which is allow, or we can do 0, 1, or 1, 0. We can do all three, right? So it's 1, 1. It's allow. So we go into the 2, right? The 2 level, and find 1, 1 is going to be 8, right? So if allow is going to be 8. So we write down 8. Allow. Okay. Then I say 0A. So do not allow A, but allow L. So we just go to 0A, 0, 1. So that's 4. So we're going to be plus 4. And then 1, 0 is just going to be plus 3, right? So that gives us 15. Right? That gives us 15. That's P. Because we have P, and then we're doing 0, 1. So 0, 1 shall be copied to the other one as well, right? So 0, 1 shall be copied. We can have a 0, 1 situation copy here, and the 1, 0 situation gonna be copied here. Okay, so that's when the first is P. Now the first is A. Now if the first one is A, that means yeah, everything is allow for that. So first one is A, and the remaining must be 0, 1, right? So we do not allow A again. So that is going to be a 1, 1 situation, right? So we're gonna only add to 1, 1. So we're gonna add to, so this is 0, 1, 0, 1, be 4, plus 4, right? Do not allow A, but we can allow L, and we cannot allow both. That's it. But if we do not allow A, but allow L, yeah, that's the only situation. Do not allow A, allow L. Right? That's the only one we can do. Do not allow A, but allow L. But that one reflects to overall is going to be allow both, because we do allow A, and then we also allow L. Or not allow, right? So it could be actually 0, 1, and 0, 0. You thought about that? Isn't that 0, 1, and 0, 0? Yeah, it should be 0, 1, and 0, 0. Oh. Let's do it one more time. Right, let's do this one more time. One more time, just trying to understand again. Okay, let's go. I'll go again. So one element. We have 0, 0. This is A. This is L. 0, 0 is a 1, right? Which means neither allow. And then for 1, we say we're gonna allow 1. Allow L, but do not allow A. So allow L, but do not allow A. So we can put L, and can always allow P, right? We can always allow P. So it's going to be L or P. That's 2, right? 2 different ways if we want to do that. And then if we allow, that's also 2 different ways. And if we want to do all 3, right? So we want to allow them all, that's 3. Okay? So now with 2 levels, A, L, 0, 1, 0, 1. 0 is just always 1 because we do not allow both. Now we say, let's say I allow A, right? I no A but allow L. So no A but allow L. That means the first one can either be P or be L. If it's P, then the second one is going to be no A but L. So we go to 0, 1. In the first one, 0, 1 gives 2, so that's going to be 2. No A but, yeah, and then if it's L, then the second one is going to be, we cannot do both, allow, because we say no A, so has to be no A but L, right? So no A but L, so that's going to be 4. That's 4, okay? That makes sense? Now we're going to do no L but A, right? So we allow A but not L. So again, first one we can say P, and the first one we can say A. The first one is P, and the second one is the same thing, not L, but allow A. So not L, but allow A, that's 2. If it's A, then because A already requires to be, next one was not A, and then now we also have no L, but A, so no A, no L. So that's give us 1. That's why this is 3. And then if we say good to go, everything is good to go. How do we combine everything is good to go? Well, everything is good to go. That means if the first one is P and the second one is good to go, which give us 3. If the first one is A, second one just no A but L, right? No A but L, so it's going to be 2. The first one is L, the second one is going to be good to go, because we only have 2, right? So it's good to go, so it's 3. But add together, it's going to be 8. Okay? Now, the troublesome comes with 3. Right, 3 values. Again, 0, 0 is 1. 0, 1, we say no A, but we allow L. Then the first position we can do P, right? No A, so no A, so P or L. If the first position is P, then the second, so the remaining 2 should be no A but L. So that's 4. Now it can also be L. If we have L, and the second one is tricky, because the second one we can start with P, or we can start with L. If we start with P, then the remaining is no A but L, right? No A but L, so that's 2. So we go back to the 1 situation, so that's 2. And if we start with L, the second one is no, right? As no, because we are LL something, and we say it's no A, and then we cannot do L again. So that's a no something, so that's 1, which give us 7, and this will be 7. Now we're going to do no L but A. If we do no L but A, what we're looking at is we can do P or we can do A, right? No L but A. So if it's P, the remaining is going to be no L but A. So it's going to be 3. 3. If it's the A, the remaining is going to be a no. So it's going to be +1. So that gives us 4. The last one is all good to go. So P, all good to go, that's going to be 8. If it's going to be an A, the remaining is no A but L. So no A but L, so that's 4. If it's an L, that have different situations. So L, we can go P, A, and L. If it's LP, the remaining is all good to go. So that's 3. If it's LA, the remaining is no A but L. So no A but L, that's 2. If it's LL, the remaining is just 1. Right? So add them together. 1, 2, 3, 4, it's 18. Okay, that's 18. All right, let's check if it is 18. Just return 0, doesn't matter. We just want to check. 3. All right, that's what we want to check. 3. Want to see if it's 18, that means we are on the right track. We're almost on the right track. We're almost. The result is 19. Jeez, come on, man. Come on. Well, we're missing something, huh? again, let's analyze it again. So we can have P in the first position, A in the first position, or L in the first position. If it's P in the first position, then the remaining two is all good to go. We don't have restrictions. So that gives us 8, because n equals to 2 gives us 8. So that's 8. If the first position is A, right, then the remaining can be just no A, right? So no A, but L. No A but L. Let's see, no A but L. No A but L is going to be 4, right? Let's see, no A but L. No A but L. So 1, 2, 3, and 4. No A but L, yeah? And then no A but L, or no. But no is already included in the no A but L. Right? No A but L, we have the no situation already included. Yeah, no A but L, we have no A. So these A, so we have LL, PL, LP, that's 3, that's 4. Right, that's 4. Okay, so now we say if it's the L, then we say the next one, if it's a P, then it's all good to go. So we go 1 position, it's all good to go, so that's, we have 3, all good to go. If it's going to be an A, then the remaining has to be just no A, right? Just no A but L. If no A but L and the 1 situation, no A but L, that's going to be 2. And then that looks nice. It looks nice. It's like garnish. Oh, lots of juice though. Yeah, I need to like split the juice in each couple at the end. Okay, so that's A, right? So it's going to be no A but L. No A but L, that's 2. Or if it's an L, then the last one shall be no L but A. Oh, I got it wrong. No L but A. No L, but that's 2. Oh yeah, that's 19. All right, I thought it's a no, but that's not no. It's just 19. All right, it's 19. Okay. All right, I'm gonna do one more. Let's do one more. We got one more, then we can try to code it. All right, so 1, 2, 3. Again, 0, 0 is be 1. That's a given. Now we want to do a 0, 1 situation. No A but L, right? No A but L, so we can do first one, we can do P. And the second one will be no A but L, so that's going to be 7. And then the second one, no A but L, so we can do L. And then L, we can do LP or LL. If it's LP, then it's going to be 2 giving me no A but L, right? So it's 2 giving me no, that's a 4. If it's LL, no A, right? So it's no. Oh, that's when we have no, right? That's a 1. So this gives us 12, right? This makes it 12. So we have 12. Now I'm going to say a 1, 0 situation. No L but A. No L but A. So we can do P something or A something. If it's P something, that's going to be the 3 situation with 1, 0. 1, 0, that's going to be 4. If it's A, and we have no L, right? So no L, so it's going to be no, that's going to be 5. Oh, all these, so this position just increasing from 2, 3, 4, 5, just always increasing. So we don't have to do that one either. So basically the first column we don't have to do, which is no L, right? If it's no L and no A, that's a 1. If no L with A, that's just the previous one plus 1. That's the only possibility, right? Now that is good. So finally, the last position is, so we're going to do again. So we're going to do PAL. If it's P, it's going to be all good to go, so it's 19. If it's A, that's going to be all good to go, so no A but L. So we are looking for 0, 1, so that's a 7. Right? Now if it's an L, then we can have LP, so that is a, what is that? That's a good to go. That's a good to go on the 2 scenario. So it's plus 8. If it's LA, right, that's going to be no A but L, right? Because we have an A, so with no A but L, so it's 2 scenario with no A but L, that's a 4. And the last one is LL. So LL is going to be a no L but A. So 2 scenario, no L but A. So no L but A, that's a 1, 0 situation. That's a 3. So add them together, it's going to give us, come on, compute. So that's 26, 34, 38, 41. Let's see, 41 with 4. 4. I'll try it. Ah, dang it. 43. Where did we got it wrong? Holy guacamole. Oh man. We'll go 2, 2, and 3. Right? So 2, 2, 3. Hold on, so we got 8, 4, 3, 2, 2. So 8, 4, 3, 2, 2. 8, 4, 3, 2, 2. So here should be 19, 7, 3, 4, 8. Did I calculate this wrong? And it could be. I was calculating in my head. 19, 7, 8, 4, 3. Well, that's 41. So one of the things was not calculated. I know for a fact that the 2 is correct. So it could be in the 3 scenario we got something wrong. All right, let's do 3 scenario again. So 0, 0 is good, right? 1, 0. 1, 0 is we allow A, but we do not allow L. If we allow A, we do not allow L, I can go P something. And if it's P something, it's going to be allow A, but do not allow L. So that's a 3, yeah? And if it's A something, and I say allow A but do not allow L, so the remaining is do not allow anything. So that's going to be 4. So I think that also is right. So what could be wrong is the 0, 1 situation. The 0, 1 situation. So we do not allow A, so no A, but we do allow L. So if it's a no A but allow L, so I can do P in the first position, and the remaining, right? Remaining has to be no A but allow L, right? If the remaining is no A but allow L, which is no A, that's going to be 4. So in the 2 scenario, no A but allow L, we have 4. Right, we have 4. Okay, and then next, we cannot allow L, right? We cannot allow L, and we cannot allow A. So 1, 1, I cannot use that. I can only use 0, 1. No A but L, right? And no A but L is including 0, 0 situation. So next one is L. So we start with L, right? If we start with L, then the next one can be P. If the next one is P, and the remaining is still going to be no A but L, right? No A but L, so it's 1 situation, no A but L, so it's plus 2. Or I can do LL. If it's LL, then no A but L, but we cannot do L again, so it's a no situation. It's plus 1, that's a 7. That is correct. It's a 7. is 7, but why is it 43? And the previous one is 19, right? We already established it's going to be 19. And it's 19 plus 7 plus 483. Because the previous 19 is acquired by 8 plus 4, 8 plus 4 plus 2, 2, 3. 8 plus 4 is 12, 15, 17, 19, yeah. Which 2 did we miss? Oh, AA is not eligible because there are 2 absences. All right, so let me count this one again. So no A, no L, that's going to be PP, yeah, that's 1. And we say no A, complete no A, so all A is count, so we have 1, 2, 3, 4. Right? I have 4. And no L, so we eliminate L, so I have 3. In total, we have 8. So that's correct. So for the 3 scenario, we can write all 19. That's actually fine. So we say PPP, right? That's that. And then we say no A but L. So we have no A but L, so we have P, right? And then no A but L, so we're looking for these, no A but L. No A but L, so we have PPP. No A but L, so I have PLP, PPL, right? And then PLL. That gives us 4. And then we say it's no A, right? No A. So again, first one can be L. The first one is L, then no A. Remaining cannot be A. So we're going to do LP. If it's LP, then no A. So we can LPP. Right? We can do LPP, LPL. Right? LPP, LPL. Because it's going to be P and L. Cannot do A, no A. Or we can say LL. If it's LL, it can only do LLP. Because it cannot do another one. And I cannot do LL. I cannot do LLA. It can only be LLP, LLL, which is wrong. So that gives us 7. Right? That gives us 7. That's correct. Then I do not know why it is not correct. So 4. Expected 43. 19, right? 7. 19, 7, 4, 3, 8. Yeah, that's 41. What are all the? Can we like list them all? I want to know. This is important. This is very important. Okay, so okay, so this is important. We want to know. This is 552. 552. I feel like I'm on the verge. Like I'm almost there, but there's just something that I'm missing right now. So what I'm gonna do is produce all possible. Is that what, like a permutation? Like ALP. Can I list all 19? That's what I want. I want to list, or not all 19. List all 43, and trying to see like which ones did we miss. Wow, that was, I don't know. Is that possible? Because the total is 3 times 3 times 3. No, it's 3 to the 4th, 81. the total possibility is 81, all right? And then, how about like elimination? Total possibility is 81. And then we say if we have any 2A's, then that's going to be bad, which means we're going to eliminate. Let's try elimination. Yeah, but I still want to know why is not right. So if I have 4, right, which means any 2, so it's going to be 4 choose 2, right? 4 choose 2, and like we have 2 values is A, and that's going to be wrong. So 4 choose 2 give us all the combinations of 2. So all of those will be wrong, okay? Next one will be we cannot have consecutive else. Or 4 choose 2 and 4 choose 3. So 4 choose 2, 4 choose 3, and 4 choose 4. Right? And that will give us, wait, do we have like an easier formula for this? I don't know. Like all possible ways to choose 2, all possible ways to choose 3, and all possible ways to choose 4. And all possible ways to choose 1. Isn't that like added together? Wait, let me see. I think added together is a value. So let's say 3 choose 1 plus 3 choose 2 plus 3 choose 3. That's 7, right? And then 4 choose 1 plus 4 choose 2 plus 4 choose 3 plus 4 choose 4. That shall be 15. Yeah, so that's just going to be 2 to the 4th minus 1. Right, so like 2 to the 4th, no, 2 to the 4th minus C4 choose 1. And that's all the combinations that we have to eliminate because that's all A's. That's all A's need to eliminate. So total is going to be 3 to the 4th. So it's 3 to the 4th minus violation on A and then minus violation on L's. Now violation on L is going to be, what is the violation on L? Well, it would be hard to, so 3 or more, right? So it's going to be, if we have 3 consecutive, and a 3 consecutive, But how are we double counting, right? How it could be double counting here. 3 consecutive, but then also 4 consecutive. Three consecutive. That's only a little bit, right? 3 consecutive. We have only 4. So like LLL is fail. 1 and 2, right? LLL is fail. So it's like a sliding window. That's only 2. And then minus 2 minus 1. Minus 2 plus 1. That is not going to give us, because 3 to the 4th, is that the total of 3 to the 4th power? Because first we can choose 3, the second we can choose 3. Yeah, this is 3 to the 4th power minus 2 to the 4th minus 4, then minus 3. That gives us 66. What are the other situations that we cannot do? It's strictly fewer than 2 days. All these situations. All right. 2 A's. It doesn't matter where they are, so the C4 choose 2, right? And it could be 3 A's, C4 choose 3, and it could be 4 A's, C4 choose 4. But 1 A is allowed. Okay, now these are like A violations. Now what we have is either no A or we have 1 A. If we have no A, right? If we have no A, then it's just going to be P and L, right? It's going to be P and L. So the only violation is going to be 3 L's. And 3 L's is only possible in these situations, right? So no A. If we have 1 A, then we have, again, like we have 1 A. It could be at different positions. So that's the first position, and then if it's all L. So okay, so we need to add more situations, right? We have more situations. The first one is A. The remaining cannot all be L. And the second position is A. Then it's actually fine because LA, LL is fine. Third, fourth, right? So we basically just add 2 more. Then that's still too little. What the hell? One way is too small, and the other way is too big. Jesus. All right, try it again. Calm down. Try it again. We have 3 situations, right? So let's do 3, right? Let's do 3. Let's do 3. So each position has 3, so 3 to the third. So total we have 27 possibilities. Now among the 27 possibilities, we can say we're gonna do 2 to the third minus C3 choose 1. That's all the situations that we're gonna have 2 A's. Oh, 2 A's. Oh, I see. Oh, I see. So this one have to times the remaining. Oh, the remaining can. Oh, I see. The remaining we can go P, we can go L. We did not take that into consideration. Okay. So we're gonna do this again. Let's do the 3 first. So 3 to the third minus C4 times C4 choose 2 and times P, right? Permutation. Besides not permutation, just the permutation. Oh, permutation. Yes, permutation of the remaining value is 2. So 2 factorial plus C4 choose 3 times 1 factorial, which is just that, and plus C4 choose 4, right? And then minus, that's when we say we have no A. Right? If it's no A, then it's just consecutive 3s. So that's just going to be 4 minus 3 plus 1, right? It's be 4 minus 3 plus 1, which will give us 2, sorry, 2, or all of them. Oh, it's not 2. It's 2 times, oh, hold on, but it's no A. So the remaining is only P. So that's 2 plus 1, and plus we have 1A, right? We have 1A, and we're going through every single position. So A is the first position, with remaining, we have to do like everything. So, but in this situation, that's just going to be, if A is the first position, and A the second position, then that's like meh, and all the way. So that's actually 2, right? So if we do that in, oh, hold on, we're doing 3 to the 4th, right? Okay, so now it's going to be 3 to the 4th minus 4 choose 2 times 2 factorial, which is 2, and then plus 4 choose 3. That's like usual, 4 choose 3, plus 4 choose 4. right? And then minus 2 plus 1 plus 2. That's 59. Still not right. Still not right. Hold on. Hmm? I'm on YouTube. All right, the 2 factorial, we just give us, no, is it 2 factorial though? So no, it's not 2 factorial, it's just like we have 2a, so remaining 2 position, each one can be 2, so it's 2 to the 2, so 2 to the 2, right? Because we have 2 positions, and I have 2 variables, so 2 to the 2, and then that should be times 2, so 2 to the second power, 2 to the first power, and 2 to the 0 power, so we're going to change that. Yeah, that's a little bit wrong. So it's not times 2, it's actually times 4, right? And then we're going to have another one times 2. And this, 43. We got 43. I think we got it. But man, that's going to be, wow. And no, go. Wait, the Python has factorial? Oh man, we're gonna compute factorial for all of them? No, they gotta be, hold on. So let me see. I want to write the function out, right? So let's do 5, right? Let's do 5 and check if we got it right. So let's do 5. So it'd be 3 to the 5th power minus C5 choose 2 times 2 to the 3rd power plus C5 choose 3 times 2 to the 2nd power plus C5 choose 2 times 2 to the 1 power plus C5 choose 4 and C5 choose 5 minus, now this is a bit tricky, so we have 5, right? And then we say if there's no A, right? No A, then it's going to be 5 minus 3 plus 1, right? Plus 5 minus 4 plus 1 plus 5 minus 5 plus 1, right? That's no A, and plus if we have A, 1A at a start. Oh, this is going to be a little bit difficult. Well, actually, no, because it's double. So A as it move along, right? A as it move along. If we have even number, so let me see, like if we have even number, A can be here, we do this, A can be here, and then, yeah, so we move 2 steps. If it's odd number, A here, and A here. So we just need to, yeah, so, okay. So A as the front, and we can write this as a, I feel like everything can be written into a like a generic function, right? So in this case, what we want to say is, given, right? Given m, length of m, how many ways can L be invalid, right? How many ways can L be invalid? So what we're talking about is m minus 3 plus 1 plus m minus 4 plus 1 plus plus m minus m plus 1, right? So if we expand this, it's going to be m minus 2 plus m minus 3 plus plus 1. So it's 1 plus 2 m minus 2. So it's going to be 1 plus m minus 2 times m minus 2, because we have m minus 2 items. Wait, is it m minus 2 items? Yeah, and divided by 2. So this gives us m minus 1 times n minus 2 divided by 2. So that is the formula, which means what we're going to minus here is going to be oh, it's going to be squares. Wait, what's the square? Like a, let's say, like 1 square plus 2 square plus 3 squares. Do we have one for this? I don't know. I don't know. This doesn't seem to be. Just like we have to add them together. Or do we? Think. We might be able to use some data structure to simplify this. Hold on. So in this case, what we're talking about is m equals 5, right? So the first item is 5 minus 1 times 5 minus 2 divided by 2. And the remaining items is going to be 4, m equals 4, right? And then 3, and then 2. 4, 3, 2. So it's 5, 5, 4, 3, 2. No, it's 5 and 4, 3. We need to double. 4, 3, we need to times 2, and then plus 2 is at the end. Oh. How can we make it? Hold on. If we do this, that's just going to be 5, 4, 3, and 4, 3, 2. For number 5. How about 6? 6 can be 6, 5, 4. If it's 6, let's see. If it's 6, 1, 2, 3, 4, 5, 6. So it will be 6, and then 5, right? And then oh, now it can be on both sides now. Oh, this is a fun. It can be on both sides. Well, the LLL is a tough thing to do. Give any position of A, it can split the thing into 2 parts, right? And it can split things into, given 6, right? It can split into 4, 1. So that should be 5, 0. 0, 5, 1, 4, 2, 3, and then 3, 2, and that's just a duplicate, so we don't have to consider. So 0, 5, 1, 4, 2, 3. Okay, and for each situation, it's going to be m0 plus 5, and then 1 plus 4, and 2 plus 3. And then the whole thing multiplied by 2, because we have the other side as well. If I can produce, but this one we can't, but can we do that? I mean, it's just iterate through. We need to iterate through anyway, unless there is a way to handle this. And a zero case is just 0 case. We don't consider 0 case, right? We don't consider 0 case. So it's just 1, 4, 2, 3. Okay. And then if we compute a 1 already, yeah, it's going to be like the whole, like a giant number, right? A giant number. 1 plus this, 2 plus this, 3 plus the blah, 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 all the way to the end. Okay, so, yeah, I think it's fun, right? So let's not do this. So we're going to minus 6, right? And then plus plus, oh, the whole thing need to, yeah, so it's gonna be whole thing, 0 plus 5. So we need to also special case, if it's a 0, it's gonna be 0. 0 plus 5, and then plus 1 plus 4 plus 2 plus 3, and a whole thing times 2. Okay, let's give this a shot. This is 5. Oh wait, this is not 5. Where does 6 come from? Come on, man. This is 5. If it's 5, then it's going to be, we take the first, right? So it divides into 0 and 4. 0 for 1 and 3, and 2 and 2. And the 2 and 2 do not double, right? 2 and 2 do not double. So it's only these double. 2 and 2 do not double. Okay. So 3 to the 5th minus 5 choose 2 times 8 plus 5 choose 3 times 4 plus 5 choose 4 times 2 plus 5 choose 1. 5 is 1. Then minus, alright, 5. 5 minus 1 is 4. 5 minus 2 is 3. 3, 4, 12, that's 6. And plus 4. 4 minus 1 is 3. 4 minus 2 is 2, that's 3. Then plus, oh, we have to double this. 3 plus 1 is 0, and 3 give us 1. Right, so that's 1. And these need to times 2. And plus 2 and 2 is 0. Alright, we have 98. What do we have? 94. Jeez. Ugh. Something's not right. Something's not right. 94. Five choose 5, so all A's, right? And then 5 choose 4, and the remaining 1 times 2. Yeah, I think this is correct. 5 choose 2, and then we have 3 remaining, and they can be 2 to the 3rd, right? And that is correct. 5 choose 3, it'll be 2 to the 2nd. 5 choose 3, 2 to the 2nd. 5 choose 4 is times 2. And if I choose 5, it's 2 to the 0. So that's good. Maybe the problem is with the last part. Okay, let's think about the last part. The last part, yeah, it's 98. Last part is a 5 completely. It says no A, right? No A. So no A, the only impossible will be 3, consecutive 3s. So it'll be 5 minus 3, right? We have 5, we can actually count it. 1, 2, 3, 4. So we can do this 1, 2, 3. So 5 minus 3 plus 1. Yes, we have 3. And then we can do 4 consecutive. Right, 4 consecutive. Oh. hold on. So when we do 3, right? When we do 3, we have 2 left. And there are 2 scenarios. Oh, geez. Yes, there are 2 scenarios. When we do 3, the 2 left, the first one has to be P, and the second one can be L or P, right? Oh my god. Oh my god. Okay, so, oof. Yeah, this has to be DP. This has to, has to DP, so, Okay, so we have 3, and then it has to be P, then the last one can be P or L. So that's actually 2. We have two scenarios for this. So I have 2 scenarios for this. And then I have 3 in the middle. 3 in the middle, only 1 scenario. And 3 at the other side. That's again 2 scenarios. So that gives us 5. Right? That gives us 5 already. 5. Okay. Now, if we have 4, if I have 4, that's only 1 scenario. So that's 5 plus 2, right? 5 plus 2, so 4, plus 1. That gives us 8. That gives us 8. So we already, so instead of 6, we have 8. 96. Which means if we have A here, then we have 4 remaining, right? 4 remaining. If we take 3, that's going to be only 1, right? That's only 1. And then here, that's 2. Right? Or if I take all of these, that's 3 plus A is here. Oh, A is here. We have these 3, but in this position, the left position we have 2. Oh, that's 2. Holy moly. And A is center. A is center is nothing. And this one times 2. So 3 plus 2 times 2. 94. Okay. I know the mechanics. But Lord, how do I do this? How do I do this? How do I do this? Like, I understand, but okay, let's first, what's the combination formula? I forgot. Let's see if I can simplify this thing. Combination formula. Which one? Khan Academy? No. I just want to know the formula. I'm not 100% sure. N factorial. So n choose r equals n factorial divided by r factorial n minus r factorial. Okay. Does this help us? We're gonna times 2 to the something power. I don't think it helped us. Does it help us? No. But factorial, right? So if we can do a prefix product, right? A prefix product. Damn, prefix product. But then what? We cannot take modulo on prefix product. It's going to be a gigantic number. We're talking about Cn, right? N could be huge. We're talking about Cn, n is smaller or equal to 10 to the 5th. 1, 2, 3, 4, 10 to the 4th. So C 10 to the 5th, choose 2. I don't think I can do it. C, it's going to overflow. Oh, but we are only doing choose 2, 2, 3, 4, but no. We're doing choose 2, choose 3, choose 4, choose the 2 to the n. But each one is multiplied by something different. That's the problem. And I cannot simplify this into a formula because it's factorial and a 2 to the power. It doesn't really fit. Alright, so it's this one times 2 to the n minus r, right? It's n minus r power. So that's n times n minus 1 times n minus 2 times n minus r plus 1. Right? That's the on top. And then bottom is just 1 times 2 times times to the r times 2 to the n minus r. That's, oh my god. How are we going to do this? I'm pretty sure if I go, I think Python has factorial. Hold on, I'll be back. This is not working. We cannot compute directly because we're talking about C 10,000. 10,000 choose 2. That's not happening. That's going to overflow. That's going to cause a lot of time. I can't even do like 1,000 choose 2. I can do 1,000 choose 2. I can do 1,000 choose 2. Can I do 10,000 choose 2? Oh yeah, I can do 10,000 choose 2. But the problem is not 10,000 choose 2, right? The problem is 10,000 choose like 10,000 choose 1,000. Yeah, it's 10,000 choose 1 because this thing just goes up. Right, we're talking about it's a Pascal's triangle, and we are, and we're starting from the second one and go all the way to the end. So that's not going to work. What might work is still step by step, right? We have to do a step by step. So either we fix our scheme to make it not 41, but 43. Let's go back to the old one. Yeah, there's a elimination directly doesn't work, but we might be able to eliminate also step by step. But I think additive is promising. All right, let's do it again. Right, let's do it again. What did we miss? So do we know that the 3 scenarios are correct? Yeah, we did. Like we try to list out all 3 scenarios, right? No A but with L, right? No A but with L, we have all this. No A but with L. Basically, L can be 1 L, right? 1 L, and then 2 L's can be here and here, and 2 L's can also be here, but 3 L's is not possible. Okay, like 2 P's, PPL, LP. Yeah, I think that is 7. 1, 2, 3, 4, 5, 6, 7. That's 7. So this is all the situations where we have no A, but we allow L. So no A, but we allow L. Right? So we have 3, no A, so we only have 2. So 2 to the third, that's the total number. That's 8, right? And then we do not allow 3L, so that's A minus 1. That's 7. Yeah, that is correct. Now we say no L but with A. So again, no L but with A. No L but with A. We talk about no L but with A. So again, we have 2, but A can only have 1. So we're talking about 3. It can be A at the front. It is no L, right? We have no L, so A at the front. That's 1. So of course, first is no A, right? No A, that's just PPP. But we have A at the front, A in the middle, A at the end, right? So we can PPA, PAP, and APP. Right? That's no A, no L, but with A. That's all that. And so finally, we're gonna say both A and L and a P, all right? And now we get up to 19, which is correct, right? Which is, what we add up is just going to be 8 plus 4 plus 3, 2, 2. 8 plus 4 plus 3, 2, 2. That's give us 19. Okay, so now we have 4, right? We're talking about 4. So no A but L shall be 2 to the 4th, right? That's total possibility. And then we just remove 1, 2, 3. We remove all the consecutive L. So consecutive L is this, and the entire thing. So 2 to the 4th, right? 2 to the 4th is 16, minus 3. Aye, that shall be 13. Hmm? 13, not 12. That's a P and L, and then consecutive 3's, right? Consecutive 3's, and a consecutive 4. That's 3. That's 13. This is 13. No L, but with A. No L, but with A. It's the same. So we have all 4, all P, right? That's 1. And then A is going to be 1, 2, 3, 4. That's 5. So 13 and 5. But it doesn't matter, right? We change this. It doesn't matter on the other side because we're not using these values. And we're missing 3. We're missing 3. So if it's P, we take everything. Remaining 3, doesn't matter. Any valid combination, that's 19. right? If we're taking A, then the remaining will be any combination, but without A. So we cannot have A again. So no A. Well, it's no A. But we can have L. So that's a 7. That's why we have 7. No A. Now if the first one is an L, and the remaining, if we can have the second position, we have P. If we have P, then the remaining position is, doesn't matter. So that's 2, doesn't matter. That's 8, right? Because it doesn't matter. It's 8. 2 is 8, doesn't matter. If it's A, L and A, and the remaining cannot have A, so we can only have L and P. If we only have L and P, that's actually 4, because we can be, it doesn't matter, we can do 4, right? That's 4. If we do L and L, the remaining, we can have, if remaining is P, then we have anything. Oh, I see. If it's LL, we have to keep analyzing this. LL, we can have the P. If the P is going to be anything, which is 1, anything 1, that's 3. What I say is no L, but with A that's 3, but we can be an A, then the remaining is going to be L or P. That's 2. L we can do A, and the remaining is no A, right? Remaining is no A. No A, 1, no A. No A is 2. Or so, and then we can now do L. That's 43. That's 43. Okay, hold on. So what this means is when we consider L, every single one, we have to evaluate. But that is trouble. That is very troublesome. Okay, so again, LP is 1 value, LA is 1 value. It's only when we have L, that's can be troublesome. So if LL, the remaining is dependent on LL, you can go LLA. It's the same. It's just LA and P and A, right? So LLP, LLA. Oh, that's just 2 rounds. So LPA, L, and then LL is also another 2 rounds. Okay. So that's 43. Let's do one more round. All right. So that's 43. 5, right? Let's do 5. Okay, so 5. Again, 0, 1, 0, 1, A and L. 0, 0 is a 1. 1, 0 is going to be 5 plus 1, it'll be 6. And 0, 1 is going to be, can we find it faster? 0, 1. That is going to be, so it's no A, so it's 2 to the 5th power, right? 2 to the 5th power, and then find how many ways we can do this. So when you do consecutive, right? So that we can use the formula, right? We can use the formula. So this one minus, so basically this is 5, right? We give you 5, how many different? So it would be 5 minus 1, 5 minus 2, that's 4 times 3, 12 minus 6. So 2 to the 5th, that's 32 minus 6. Was 26. Okay, this one's 26. That's easy to calculate. So 3 values are easy to calculate. Now the last value is going to be 43 plus, right, so 43, so P is done. A is done. A is going to be a not A but L. So it's going to be 4 level, right? So 4 level, not A but L, that's 13. So this one plus 13. These are done. There's a done deal, right? Done deal. Now, the remaining is interesting. The remaining is L. The first one level is L, right? And I will have 1, 2, 3, 1, 2, 3, 4, 5. So first one is L, and then we can have LP. LP is 3 level all in. So it's be plus 19, right? LA is going to be 3 level, no A. 3 level, no A. That is going to be 7. 3 level, no A. That is 7. Okay? Now it's LL. This is interesting. If it's LL, then we need to analyze again. We're going to have P and A. So it's 2 level, right? 2 level all in. 2 level all in is 8. Or A, that's 2 level. 2 level, no A. 2 level no A is 4. So we just add this 2 and add this 2. So in total, what we have is 43 plus 13 plus 19 plus 7 plus 8 plus 4. 94. Okay, I think we got it. And if we look again, it's 43 plus 13 plus 19 plus 7 plus 8, 4. So the no L situation is completely useless. We just need to sum up all the with L situation. So with L we have no A or with A, right? So no A, that one we need to compute for each one, and with A we compute it. So we only need these two. And we only extend back. So we calculate 5, right? We'll expand back. We need to go 4, 3, 2. So we compute 5, we need the 4, 3, 2. We need to compute 6, we need 5, 4, 3, right? Yes. And then the left side doesn't really matter. And then we can compute like 2, right? 2, we need just how do we evaluate 2? So 2 is a special case because there's no L. We have so we'll go P, and that's 3, right? And then we'll go A, that's 2, and we'll go L. Well, if we go L, then we go P, L, that's 3, it's 8. So that's more of a special case because we only go back two levels. But now we go 3, right? Then we go back 8, 4, 3, 2, right? Is that 8, 4, 3, 2? 8, 4, 2, 3. 17. No, because if we have 3, first level is P, then we have 8. Then if we go A, right? If we go A, that's 4. If we go L, we can go LP, that's 3. LA, that's 2. And LL, if it's LL, we need to go further up, right? But further up, we're going to say it's either P or A. That's why the last two. Therefore, these are the three scenarios that we have to consider. So, here is what we're going to do. Here is what we're going to do. Okay, so what we're going to do is all in, right? I'm going to say all in. When all in 1, all in 2, all in 3. So, okay, so if all in equals all in equals 3, 8, and 19, right? And then no A but L. No A equals all in and no A. No A equals 2, 4, and 13, right? So we need these three. And then we say if n is smaller or equal to 3, right? I'm going to return all in n minus 1. So n is starting from 1, yeah. So we do, yeah, we're going to do all in n minus 1. Otherwise, we're going to say for I in range, right? So I in range what? So this is 0, 1, 2, 3, right? I mean 3 to, what is I? I is, no, actually 4. 4 to n plus 1. So I is actually n, right? And now we just need to find which is actually, we can just do 3 to n, right? We can do 3 to n. Now, this value is going to be equal to, let's see, 19, 7, 8, 4, 3, 2, right? So it's going to be, we're going to shift everything. I'm going to shift everything. Hold on. Can we make this one? What if we use a deck? Or we just say, we find all in, right? And then we find no A. So we need to say all in 0, right? All in 1 and all in 2 will equal to all in 1, all in 2, and all in, that's the new thing. So all in 2 is the new thing. That's going to be the sum of all in, sum of previous all in, 1, 2, 3, sum of previous all in, and a plus sum of previous no A. Right, so we got this, and then no A 0, no A 1, and no A 2. That going to be equal to no A 1, no A 2, and the new no A is going to be 2 to the some power. Two to the, oh, come on. 2 to the n. 2 to the n. I mean, if we go 2 to the n, we might as well just say 1 left shift n. right? I think that one was faster. So 1 left shift n, and this one minus n minus 1 times n minus 2 divided by 2. That's the total possibilities. And this is the total number of ways that triple L will happen. So we do this, and then we keep going until the end. But we need to modulo. So we have to modulo this. So mod is equal to 10. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one is 7. So every single one, this we need to mod, and of course this we need to mod as well. This we need to mod. And then once we're done, we're going to return all in minus 1. Alright, so let's give it a shot. So, of course, we can do 2 is 8, we know. 3 is 19. This one, that's fine. 4 is 43, we know. 5 is 94. We don't know 6, but we do know 1 is 3. 1 is 3. And then we have this boy. This boy, 10,101. I'm going to return this value. Alright, and then this is going to be n. This is going to be check record. And we are off. We are off. Of course, these 3 will pass. That's not the issue. Now, 4, right? So 3 to 4. So I is equal to 3. Right? Actually, don't use I. And then we simply compute sum all in. I think it's because the all in is already changed. How about this? New all in equal to this. New all in equal to this. And then this equal to blah blah blah. New all in. New, but no A is fine. No A doesn't really matter. Try this. Nope. Why does it take so? Oh, this one takes a long time. Oh man, we might time out. I spent so much time. We'll probably time out at the end. That would be very unfortunate if we time out at the end. Hold on. Why is it 49? Let's add it. So it's what? So it's should be 2 plus 3 plus 4 plus 8 plus 13 plus 13, right? No, plus 19. All right. So something does not add up. Something does not add up. So 3A19. 3A19. No A is 247. 4. This is 7. 7. That's why. Pass. Okay. This one does not pass. trouble. I think this is not n, this is I. Right? It's not I, it's I plus 1, I think. And this is I plus 1. Because we're considering the current situation. So this is I plus 1 is the current value, 4, right? So what is I plus 1? Ah, this is just looking really ugly. So 2 I plus 1, right? That's the total possibilities. And then minus going to be I plus 1. This would be I plus 1, I minus 1. Okay? We pass these two, but we fail on this. Why is that? I think we can also put this one here. I think it's possible to do it this way. Wow. Look at this time difference. Yeah. Mu no A equals this. And then this is mu no A. Ah. Alright, we have issue. We have issue. Let's go 6, 7, 8, 9, 10. We have a problem. We have a problem. 202. 6 is 202. 6 is 202. No, 6 is 200. We're adding more. 7 is 418. 8 is 861. 9 is 1753. And 10 is 3536. We're off by a little bit, but then eventually it will grow. Okay, so what is the problem? Let's do 6. All right, let's do 6. So we have 1, 2, 3, 4. What's 5? 5 is 94, and 2 to the 5th minus 6. That's what I think, 26. But I'm actually not sure. Calculate it. 2, 3, 4, 5. This is what? A. No A but L. Right? No A but L. No A but L. How many different ways we can do no A but L? So 2 to the 5th, right? So 2 to the 5th power. 2 to the 5th power. That's 32 different possibilities. Now we need to remove 3. Oh, we need to remove a little bit more. I see. Right? So with 5, no, we need to do 5, 5, 5, 5, 5. 1, 2, 3, 4, 5. So these 3, and the remaining is 2. Nice. Oh, how do we do this? Remaining is 2. So yeah, that's 2. Dios mío. That's basically is a P, right? It's a P, and then the remaining, the maximum we can get. The maximum we can get, that's just 2 to the whatever power, 1 power, right? So it's going to be 5 minus, and then we move to the center. Oh wow, it's tiny. So it can be in the middle or it can be on the right side. But as we grow bigger, darn it, how do we compute this? Like without doing this. So what we want to compute is no A but L, right? So no A but L. 2, 3, 4, right? Oh, that's great. It's small. No A but L. Okay, to compute no A but L, we can say first is P, no A but L. So the remaining is going to be no A but L for the smaller, right? So that's going to be 7, right? 7. Or we can say it's going to be L, right? If it's going to be L, then the remaining 1, 2, 3, 4, no A but L, so we can go P, which is it'll be 3 level, right? 3 level. Wait, hold on, what are we doing? We're doing 4 level. Oh, we're doing 5. So if it's P, it'll be 4 level. That's 13. 13 plus, oh, okay, we're trying to validate 4. We're trying to validate 4. So that's be 7 plus, that's 3 level, 4, or we can be L. If it's L, then we can do P, right? So it's be 2 level, 2 level. Wait, no, that's not 2 level. We're looking at 4, right? So it would be L, and then we have LP is a 2 level, no way, that's 4. Or we can do LL, that's going to be P, so it's 1 level without A, that's plus 2, that's 13, okay? So if we have 5, right, about 5, if we have 5, then the first one is going to be P, so it's 4 level without A, so 1, 2, 3, that's 13, and then the first one can be L, and the next one can be P, so that's a 3 level without A, that's 7, or next can be L, then the third one has to be P, so that's 2 level without A, so plus 4. So that add up together is 24 instead of 26, right? That's 24. So we add 2 less. Okay, yeah. So this cannot be computed. So this is correct, right? And this is all good, but this is not correct. This is not correct. How do we compute it? So this is 13 plus 7 plus 4, right? Which means that's 7 plus 4 plus 2. So that's just a sum of no A, right? The sum of no A, the previous sum of no A, that will be the result. 7 plus 4 plus 2, yeah. And then 13 plus 7 plus 4. So if we do this, and everything pass. Okay, so we don't need this, because if n is smaller or equal to 3, this one will not enter, so we just do this. All right, so no A, all in, and then let's also test the rest. And most importantly is this one. There we go. Nope. N minus 1. Right? Nope. We got index out of range. So it's going to be the minimum of n minus 1 or n minus 1 or 0, 1, 2. That's the thing. Alrighty. We run one more test case, one more random one. So 10,000, 1, 2, 3, 4, 5. 10,000, see how fast it goes. Yep. Submit. Come on. Show me the green. Show me the green. I got the green. Oh my god. We got this. Wow, what a struggle. And the final thing is so simple, right? The final thing is so simple. No A and all in, and that's it. I'm pretty sure this is the solution. So runtime, we're gonna write a lot. We're gonna write a lot. All right, let's do this. So, well, what a problem. Okay, so let's try to explain this. Here's the thing we need to focus on. For each, so we focus on two scenarios. Right? Two scenarios. One is that two scenarios given in n. One is that there is no restriction, right? When there's no restriction on the choices of P, A, and L. The other, we call the results, we call the number of arrangement, right? Arrangements in this scenario all in. The other is that we cannot use A, which we name it no A, right? All right, so we can manually construct all in and no A for n equals 1, 2, or 3. These are the base cases and quite straightforward, right? Base cases. And while doing so, we realized that to compute, we realized that using 3 previous results, we can compute the 4th result. Here is how it goes. Right. To compute the 4th, right? To compute the new all in, right? To compute new all in, with length n, we can put p at the first position, right? P at the first position. Then we need all in 2, right? Then we have the total arrangement is all in n minus 1. We can put p, right? We can put a at the first position. A in the first position. Then the total arrangement is no a n minus 1. We can put L in the first position. Then we can put P in the second position, which gives us, put in the first position, arrangement is this, right? Then we can put say put P, right? And this is put A in its first position. Then the arrangement is this, right? And then let's say put L in the first position, and then we have put P in the second position. Then the total arrangement is all in n minus 2. Right? Put A in the second position. Then the total arrangement is no A n minus 2. Put L in the second position. Copy these two. Put P in the third. Let's not do first. Let's call it first, right? And then this will be second. And then this will be third position. This will be third position. Length n larger than 3. Put A in subposition, then the total arrangement is n minus 3. This is n minus 3. And that's it. Thus, the new all-in, equals all-in n minus 1 plus all-in n minus 2 plus all-in n minus 3 plus no A n minus 1 plus no A n minus 2 plus no A n minus 3. Right? And since we only need the past 3 values, we can restrict all in and no A to an array of size 3 then new all in equals sum all in plus sum no a, right? Equals this plus this. Yeah, this is important. Similarly, we can obtain the formula to produce new no a, right? The new no a, we can say put p in the first position. So this gives us p in the first position. This gives us no a and minus 1. Put L in the first position. Then we can say put P in the second position. This gives us no A and minus 2. And then put L in the second position. Then put P in the third position. This gives us no A and minus 3. And we're done. Right? So new thus new no A equals no A, the sum of these, right? The sum of this. And we can also or we can write it as new no A equals sum no A. So using these two formulas, we can obtain the values for each n. For each, we can obtain the value for each number from 1 to n. And once we reach n, we return we return all in minus 1. So runtime is on runtime, and that costs us 12.76 milliseconds, or a 54% ranking. All right. Wow, this is a good question. People don't like it. All right. ONDP thinking process. Oh, it's long. Oh my god, so long. Alright, I'm gonna post mine. I don't want to read any of these people's posts. I'm just going to post mine, and I feel like mine is 4 lines. Oh, I can boast how many lines. So it's not necessary. So yeah, let me post mine using NumPy. Alright, we already spent a long time here, so let's just post this and call it there. What will be the name for this? That will be all in and no A solution. all in and no A solution. Ta 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 ta. Right. Post. Yeah, it's my understanding of this problem. All in and no A. It doesn't make any sense, right, if you're just looking at it. But, wow, what a problem. I mean, I can even make it simpler, right, because I have the sum no A, I compute it twice.